Hello, Algebra 2 students. This is an essential lecture on section 4.3, which is factoring when it looks like x squared plus bx plus c. Okay, the methods that we will be discussing today only work when there is no number in front of the x squared. If there is any number here other than 1, then you're going to have to use an additional or a different method. We're going to have a bunch of terms here. And you guys are going to bear with me here in understanding these. First up, we have a monomial. A monomial is an expression that is either a number, okay, a number, something like 3, a variable, something like x, or the product of a number and a variable, something like 3x, right? Those would all be considered monomials, 3 or x or 3x, or I will say even something like 3x squared would be a monomial. Okay, the product of a number and a variable. A binomial, so mono meaning 1, binomial would be 2 of these monomials being added together. A very common binomial would be something like x plus 3. And then you guessed it, a trinomial would be 3 of these things all being added or subtracted with one another. Something like 3x squared plus x plus 3. Okay, monomial, 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 all of them are being added or subtracted together. That would be a trinomial. A quadratic equation is our next term, and this would be an expression that could be written in this form ax squared plus bx plus c. So something like this here, this trinomial that I wrote, if I had said 3x squared plus x plus 3 equals 0, this you should identify as being an example, right? The a term is 3, the b term is 1 in this case, and the c term is also 3. This would be an example of a quadratic equation. The purpose of chapter 4 as a whole, okay, if I'm saying, hey, big purpose, what are we trying to do? We're trying to solve these quadratic equations. Linear equations, okay, think back to previous chapters, would be something like 2x plus 1 equals 0. For linear equations, solving them is as simple as getting x by itself. For quadratic equations, we have multiple x's. We're no longer able to use that as a method for solving these quadratic equations. We're going to have to use something else, something more complicated. And all of chapter 4 is dedicated to finding ways to solve these quadratic equations, starting with this lesson, 4.3 on factoring. Factoring is one of the easiest ways to solve these quadratic equations. It's very efficient. And we're going to be using it all the time, and we're going to be using it through the rest of the year. So please make sure that you understand this section. This is one of your core pivotal sections. Up next, we have the root of an equation. I'm going to add some things here. A root of an equation is what we call the solution, the value of x that makes this true. We might call that a root, or we might call it a 0, or we could call it a solution. These all mean the same thing, okay? What we're saying is, what values of x make this true? For linear equations, something like this, the answer or the solution to this problem, if you guys actually solve for x, it would be x equals -1/2. For quadratic equations, most oftentimes there will be 2 solutions, not just one solution like x equals -1/2. There'll be solutions like, hey, x could equal -1/2 or x could equal 4, for example. So those solutions might be called solutions, or they might be called zeros, or they might be called roots. And then we have a property that makes this all work, and it's a very important concept for you to understand. I really want to emphasize this. It's called the zero product property. And what the zero product property states is something that might seem really trivial or non-important or not interesting. However, it really is what makes this whole factoring thing work. So picture this. We have 2 numbers, A and B, right? And they're being multiplied together, and we get a solution of 0. So we have a number, and we multiply it by another number, and their product, their answer is 0. What the zero product property states is if that is true, if two numbers multiply to 0, then either A must have been 0 or B must have been 0. Okay, think about that with me. If two numbers multiply together and they equal 0, then either A is 0 or B is 0. If you can find two numbers, okay, this will be a challenge. If you can find two numbers that you multiply them together and they equal 0, but A nor B is 0, you and I, you tell me about it, and then we'll be really rich, okay? Because that would be super fascinating mathematically if you could find something that works, and don't spend too much time on that because you just won't, okay? If two numbers multiply to 0, either A must have been 0 or B must have been 0. All right, next up. This is from a previous section. We had something like x plus 3, and we were multiplying it by x minus 2. And the terminology that I told you guys to use for this was to FOIL. And we talked about the terminology of foiling. And really, foiling is just something that we say, but really what we're doing is we're taking this binomial, right? This is two terms. They both are monomials. They're being added together. This is a binomial, and we're multiplying it by this binomial. And what we need to do to multiply them is you would do first times first. X times x is x squared. And then outside one times outside one. The outside one is x over here, and the outside one is negative 2 over there. And x times negative 2, I want you to get in the habit of writing the coefficient, or the number first. That would be minus 2x. Then the inside two need to be multiplied together. That would be those two. That would be 3x. And then the last one from this term, the last one from this binomial, and the last one from this binomial need to be multiplied together, and they would be negative 6. Essentially, just if you don't really like the foiling terminology, you multiply this term by everything in the other binomial, and this term by everything in the other binomial. That was what we just did. This process is going to get longer because we're eventually going to have more terms here and more terms here. That same idea will hold. We're not done yet. We need to combine our like terms. X squared, negative 2x and positive 3x would just equal 1x, or x minus 6. So we call this foiling. What factoring is, okay, the whole point of this lesson is going to be doing the reverse of that. Okay, remember, foiling was going from this statement here to this statement. What factoring is it's going from this statement to this statement. We're doing the reverse of FOIL. So how are we going to do that? Well, here is what you are going to do. So here's what you are going to do. Our statement is x squared plus x minus 6. The answer we know is going to be x plus 3 and x minus 2. Well, how do we get that? Here's the thing that makes factoring work. What you're going to do is you're going to always put it into two sets of parentheses, right? And you're just going to know this, x squared. We need the first term and the first term to multiply to x squared. X and x will give us that, right? X times x, remember we did the first term times the first term and got x squared. So we know x and x are going to go here. In the last one, need to multiply to negative 6. So what you're going to do is you're going to take the last term and you're going to list the factors of 6. The things that multiply to 6 would be 1 and 6 and 2 and 3. You with me? Those are the only things that multiply to 6, the only two integers. Now we need to look at this and we need to say which one of these pairs could add to the middle term. And our middle term, if you recall, is the number 1. So we need to add to positive 1, and our options are either 1 and 6 or 2 and 3. Now, hopefully you guys, when you guys look at this, are saying, well, 1 and 6 could never add. If I used addition and subtraction anywhere I wanted to, it would never get to 1. It could get to positive 5, positive 7, negative 5, depending on where they put the positive signs and the negative signs, but it'll never add to positive 1. 2 and 3, on the other hand, could add to positive 1. If I made this one negative and this one positive, now these things add to positive 1. I'm going to emphasize that I got this right. Here's what I'm going to do. I'm going to say, okay, do these two things multiply to negative 6? Yes, they do, right? Negative 2 times 3 is negative 6. And do these two things add to positive 1? Once again, yes, negative 2 and positive 3 does add to positive 1. So what goes in the parentheses here is going to be negative 2 and positive 3. You'll notice I have a different order to what I said the answer was, but that order doesn't matter. What matters is that the positive sign is associated with the 3 and the negative sign is associated with the 2. Here's my solution. Let's try some other ones. So we have x squared minus 3x minus 18. What you're going to do is you're going to list the factors of the last term. That's always where you're going to start. Okay, what are the factors of 18? Well, we have 1 and 18, 2 and 9, and 3 and 6. We need to find which of these factor pairs, this is a factor pair, this is a factor pair, and this is a factor pair, could add or subtract to negative 3. Okay, 1 and 18. 1 and 18, if I got to pick the positive signs and the negative signs, would add to either 19, 17, negative 17, or negative 19. That's the only thing that 1 and 18 can add or subtract to. Depending, like I said, I get to pick the negative signs and the positive signs, but 1 and 18 can never get to negative 3. 2 and 9 will either get to plus or minus 11 or plus or minus 7. Still never getting us to negative 3. But 3 and 6 could get you to negative 3. The way that 3 and the 6 would get you to negative 3 would be if the 3 was positive and the 6 was negative. Let's confirm that this actually worked. Do 3 and negative 6 multiply to negative 18? They absolutely do, right? 3 times negative 6 is negative 18. And positive 3 minus 6 is negative 3. So this is going to factor to x plus 3 and x minus 18. If you're wondering if you got this right, I encourage you to pause the video right now and FOIL this statement. First time's first, right? FOIL this. You should get back up to here. Let's continue moving on. We have more stuff to cover in this lecture. In this example here, once again, you go to the last term. You list the factors of 9. The only factors of 9 are 1 and 9 and 3 and 3. So how can we pick these factor pairs to get to negative 3? Could 1 and 9 ever get us there? Could 3 and 3 ever get us there? How would that happen? Well, guess what? Not everything is factorable. 1 and 9 can only get you to 10, positive or negative 10, or positive or negative, well, 0 or 6, right? That 3 and 3 could either get you to 6 or negative 6 or 0. So none of these could get you to negative 3. This problem is just not factorable. I told you we're going to learn a bunch of different ways to solve quadratics. Factoring just doesn't work for all of them. Okay, this is an example of something that is not factorable. These are both considered special cases of factoring. This problem here, you're going to notice doesn't have the middle term. I know it doesn't have the middle term because the middle term is the one that just has a plain x, and this one has the x squared term, and it has the one without an x, but it doesn't have that middle term. So it still has a c. We can still go to the c term and list the factors of it. The factors of 9, we just listed this in the last example, are 1 and 9 and 3 and 3. Our middle term here is 0. We need to pick the factor pairs, 1 or 9 or 3 or in 3, that would get you to 0. And if the 3 here was positive and one of them was negative, now they do multiply to negative 9 and they do also add to 0. So this factors to x plus 3 and x minus 3. We're going to see a pattern here, okay? And we're going to talk about that in the future. But there's going to be cases where the middle term is 0, like this. They're really easy to factor if you identify that this is a perfect square, okay? X times x is x squared, and 3 times 3 is 9. They're both perfect squares. And that's how it's going to factor x plus the perfect square and x minus that perfect square. This one is also considered a special case. The factors of 64, there's a decent amount of them. We have 1 and 64. We have 2 and 32. We do not have 3, but we do have 4 and 16. No 5, no 6, no 7, 8 and 8. So which of these factor pairs would get you to 16? Think about it for a second. Hopefully you land on positive 8 and positive 8. Identifying that 8 times 8 is 64, and 8 plus 8 is 16. So when you have x plus 8 and x plus 8, I don't ever really want you to write it like this. We have a binomial being multiplied by itself in this case. So we'd factor to x plus 8 squared. Examples where you have an equals 0 at the end are not any more difficult, really. Pretend that the equals 0 isn't there to start. Factor it the same way. That would be 1 in 42, 2 in 21, 3, 42 divided by 3. What, I don't know what, 6, no, 5, no, 14, 14. 4 doesn't work. 5 doesn't work. 6 does. 6 and 7, right? So our middle term here is -1. We need to pick the factor pair that gets you to -1. 1 in 42 never would. 2 and 21 never would. 3 and 14 will never add to -1. But 6 and 7 could. If the positive sign was with the 6 and the negative sign was with the 7, this would factor to x plus 6 and x minus 7. So we factored it just the same way with this equals 0 at the end. Now, this is going to start to utilize that zero product property that I mentioned earlier in the lecture. Remember what I told you guys, is that if you have something and you multiply it by something else and their product is 0, we know that either A must be 0 or B must be 0. So this is my A term here. X plus 6 is my A term. What you're asking now is what would make this 0? Because this is going to be multiplied by something else. And if I can find out that this is 0, then it doesn't matter what it's being multiplied by. The answer is going to be 0. So what makes this one 0? There's two ways that I could think about this. I could set it up. X plus 6 equals 0 and solve for x. Subtract 6, subtract 6. X is equal to -6. But I probably don't need to do that. I can probably just look at it and be like, hey, -6 makes this one 0, and +7 makes this one 0. So -6 and 7 are my solutions for this problem. Last problem here, potentially, I don't remember. This one, same idea. I would pause it here, try it out. What multiplies to -14? There's not a lot of options. 1 and 14 or 2 and 7. Which of these could get you to +5? Well, if the 2 is negative and the 7 is positive, these things multiply to -14 and add to 5. So it'd be w minus 2 and w plus 7 equals 0. Now you ask yourself, what makes this set of parentheses 0? That would be 2. And what makes this set of parentheses 0? That would be -7. And those are my solutions. Very easy to check your work here and maybe potentially even satisfying. If you plug 2 in to the equation, 2 squared is 4. Plus 5 times 2, that would be 10. Minus 14, hey, that's 0. 4 plus 10 is 14. 14 minus 14 is 0. I could do the same with -7. -7 squared is 49. Make sure you plug that in with parentheses around it if you're typing it in. 5 times -7 would be -35, and -14, that's also going to equal 0. So both 2 and -7 would work. And the last examples that I want to talk about are these unique examples where the C term is the one that's missing. We already talked over here about what to do when the B term is missing, right? You still go on and the B is just 0. When the C term is missing, right? No C term. By definition, if there's no C term here, if I cover this up, they both have an X in common. And so this is going to be something that we're going to utilize a lot, is we're going to undo the distributive property with what they have in common. And what both of these have in common is an X term. And so I'm calling it undoing the distributive property for now, but I'm just going to start to call that factor out an X. And what I mean by that is you take it outside of the parentheses, and then whatever's left in the parentheses would go here. So if I take out an x from here and here, what I would be left with, there's two x's here, right? This means xx. So one of them is out front, one of them would be here. And then if I take out the x from this one, this would just be minus 7. Now for a second, I want you to verify that this is actually equal to this statement. If you were to distribute this x back in, you would get x squared minus 7x, yes? X times x is x squared, x times negative 7 is negative 7x. So these are two equal statements. Now, we're going to utilize that zero product property again. This is the a term, and this is the b term, and they multiply together to equal 0. That means that either this must have been 0 in the first place, or this must be 0 in the first place. And you're going to ask yourself what makes each one 0. And they both should be very simple. What would you plug in for x here to make this 0? That would be positive 7. And what would you plug into this x to make it 0? Well, it's just x. So if you plugged in 0, it would work, right? And now we can go back up to the top and verify that this works. 0 squared is 0. Minus 7 times 0 is also 0, right? So 0 is a valid solution, and so is 7. 7 squared is 49. And negative 7 times 7 would be negative 49. And that also works. So our answers, our solutions here are 0 and 7. And then this last example is going to be really similar to this one here, except we have an additional first step, and I want to take a minute to clarify something else, that this factoring only works when it's set equal to 0, right? Or the solving method that we have where factoring works only will work when it's equal to 0. So our first step is going to be to move this 5w to the other side so that it is equal to 0. And the way that we would move it is by subtracting 5w. So we'd have w squared minus 5w is equal to 0. Now it looks a lot like this example over here. They have a w in common, right? We're missing the c term, so they both have something in common, and I can factor that common thing out. They have w in common. And if I take out a w, what I would be left with is w minus 5 equals 0, giving me solutions of 0 and 5. I want to encourage you guys to reach out to me if you guys have any questions. I would love to help you with those. Good luck.